My name is Jean-Paul Moniz. I'm the Technical Services Coordinator for Cameco Fuel Manufacturing in our metal fabrication plant in Cobourg. My responsibilities sort of cover maintenance operations, capital project planning, and then I also oversee operational technology. So who are we? Cameco Fuel Manufacturing is one of two suppliers serving the Canadian CANDU reactor fleet. We are the largest based Canadian fabricator of in-core CANDU reactor components. Like I said, we have two manufacturing facilities, a metal fab manufacturing facility that manufactures all the subcomponents that go into nuclear fuel bundle manufacturing, and then our bundle manufacturing facility where we actually pelletized uranium dioxide into pellets, load it in the fuel tubes, wall it up, assemble it up into a bundle, and then ship it to our customer. So then you ask, what's the importance of operational resiliency for a nuclear fuel fabricator? And I would think a lot of us in this room probably think that's a good idea. Yeah. And it is, and for us, this talk today, when we're talking about resiliency, it's more about making our infrastructure resilient, right? And so, it starts with, the equipment that we use to do work, right? And creating that, resilient infrastructure so we can sit there and support operations. So this is what our current architecture looks like right now within the Cameco Fuel Manufacturing business. We do sort of have an enterprise type architecture with our two ignition gateways at each site. Our operational technology is basically centered around ignition as a platform. We use it all over the place. About in 2010, we started using it for mainly equipment downtime tracking. From that use case, we deployed it fully in 2011. 2019, we started using the MES functionality that their partner modules provide. Did that to a single manufacturing line. Used that as a use case to deploy it across our entire both facilities. We successfully deployed it in our metal fab facility. We just finished that deployment, and we're about 75% completed in our other facility. And then we're looking at what we can do with, DevOps and utilizing cloud technologies and edge technologies to sit there and bolster that infrastructure. As we've as we've developed ignition as a platform, we've built so much functionality into it. So it's doing MES functions, it's doing, production downtime tracking. We're using it for condition-based monitoring of assets. We use it for visitor login into our facility, a whole bunch of different things. You can think of the complexity and all the different use cases, and how do you properly test that out? Right now, when we develop, we have, virtualized development environments, but they're not, fully integrated into our process. And so working with 4IR, what we're looking at is a sort of future state architecture. Excuse me. Future state architecture where we utilize the benefits of cloud technology. When you start talking about, building up dev environments or QA environments, I don't really want to have those things running all the time. I don't want to have to pay for them all the time. I sort of use them when you need them, that kind of stuff. And then also being able to sit there and test out new feature sets that we include into the platform without incurring production downtime. And that's a really difficult thing to do right now, right? So you can imagine as a manufacturer that's operating 24/5, sometimes maybe 24/7, how do you schedule those outages to get, a new feature deployed into the production environment without taking the production environment down because of maybe, something that wasn't tested fully or a dependency that wasn't met or whatever that case may be. So by using this looking at this new architecture that we're trying to deploy, what we're able to do is fully vet out all of these, application enhancements or version upgrades of the platform, or whether it's a module upgrade, whatever it may be. And then we also get to sit there and eliminate a lot of our operating costs, or at least shift our operating costs to provide better value somewhere else, right? Or create capability, mainly create this DevOps capability. So it allows us to simplify, Ignition as a platform supports containerization. So now I can sit there and just, deploy it as a container. I don't have my Windows operating systems anymore. I don't have to worry about patching the OS. I can just worry about the containerization technology and making sure that's up to date. And by doing all this and deploying this architecture, we're actually finding that we actually will likely get like a 5-year payback by getting rid of our traditional IT infrastructure that supports Ignition, moving to, hardware as a service, infrastructure as a service with 4IR. We shift those costs, but then we also get payback by not having to invest in some of the things like SQL licensing, for example, or Windows licensing, all that kind of stuff. So, sorry. So why are we looking in the hybrid cloud, like I talked about, right? The scalability and flexibility for us is kind of an advantage, right? As we develop those new features, if we need, more CPUs, if we need more memory or whatever, we have that flexibility of just adding it into the environment, right? And we can add that in at dev time, and if everything works out, okay, then we can move it into production. We get better visibility because all of our environments are running on the same control plane. They're running essentially on the same infrastructure, whether it's up in the cloud or down at the edge. And then enhanced security, right? You sit there and you take a look at our environment right now. We have, like I talked about, we have the OS environments. We have different instances all over the place and whatnot. Now we get to eliminate and simplify a lot of that. And then also with Ignition as a platform, a lot of the front ends are, the front ends are all web-based, and we're moving over to perspective from vision. And that allows us to run the front ends on standard build computers, right? And so we get better control over the client devices that we're running the software on. And then the hybrid edge infrastructure is sort of a key piece to this because, it allows us to bring services from the cloud down to the edge, right? And so, everybody talks about, well, if you run your manufacturing environment up in the cloud, what happens when the wire gets cut? Well, with the hybrid edge infrastructure, that allows us to run those, critical manufacturing workloads on the edge in the plant, right? And so if we lose a control plane, if we lose that connection, we could still run at the plant and then, fix that connection and then return our cloud services. And then the big piece for us is we get this whole added capacity of best-in-class IT strategies in the OT space. So we get improved change management, right? And you can imagine in a regulatory environment, change management is, one of our foundational elements, right? And so now we get to sit there and apply, Git-based type revision control and solid change management processes against our OT environment. And for OT environments, that's, largely unheard of for, especially 15 years ago. And then we get realistic testing environments, right? Again, one unique situation about OT environments is it's hard to get a testing environment that's almost carbon copy from production to dev, right? Like I can't copy a manufacturing line, right? Unfortunately, I don't have a test manufacturing line to sit there and be able to test my system full stack. But using the architecture that we're looking at, it allows us to get as close as realistically possible. And in the next slide, I'll talk a little bit more about that. And then again, cost-effective infrastructure. We're paying for what we need, and we're not paying for what we don't need. And then again, security. Because we're using DevOps and we're doing that change management, we're trying to keep everything up to date. If I can keep my OT environment up to date, as close to up to date as I can keep my ERP, for example, then that's a win-win. So considerations, obviously, like I talked about, we want to keep environment differences to a minimum. That's a very hard thing to do in the OT space. One of the key things you can do is by sitting there and carving out your actual live data, so your controller data, your PLCs and everything like that, and pulling it out into sort of a unified namespace concept, using technologies like MQTT and whatnot, allows you to provide a sort of unified data platform for all the different environments. So my dev environment's pulling from the same data that my production environment is pulling from. And then you can also do some really smart things with, if you think I'm pulling data out of my manufacturing floor to do stuff with it, and then if I sit there and return information back, I can carve out these neat ideas about development namespaces or QA namespaces to sit there and be able to get closer to that ideal of being able to test full stack sort of thing. And then figure out what should be different across environments. Again, maybe device connections have to be different because of a technology it's using or whatever, but try and eliminate that if you can. Database connections might have to sit there and differ, connections to ERP systems and whatnot, and then your IDPs and all that kind of stuff. And then what you can't, make the same or unify across, then document what's different and follow that. And then also, adding to the stack, this is very ignition centric, but if we're sitting there talking about change management, there's PLC code change management. Right now we use Asset Center to do that. We're looking at other products that fit into this architecture. So we have, a unified seamless sort of revision control architecture. So adding in revision control of our PLCs, CNC machines, robots, stuff like that.